Nope, we're taking them back to reality. We're out of story problems, which is the good news. Yay, we're out of story problems. You can do story problems at least for a while. Story problems do come back multiple times in the year. But okay, so we're out of story problems, but that means we're also back to reality of chapters in the textbook and taking normal notes and things like that. Okay, however, there is a high note here. We are going to start our next unit over inequalities. Okay, and the good news about this is that inequalities are very, very, very similar to equations. Okay, so if you did well in the equations unit, you should sort of feel like, oh, okay, good. I've already got a foot in the door. That's going to go pretty well. If there are things that you struggled with in equations, this is your chance to correct and fix them. Because we are going to go through many of the exact same processes that we did before. Now, hopefully we've heard the word inequality before. What is an inequality? I think we know probably.
Can you do like it was like, because like I know I just don't know it. It's not even.
I mean, I would get, oh, not exactly, but it's other signs other than an equal sign.
Oh, like greater than?
Yeah, there we go. These symbols. Right? Those are inequalities. Now, here is the deal. There can be no alligator mouse happening at this level anymore. So when I say what sign is this or what sign do you want to use, you can't go, well, I want it to eat going this way. No. Yeah, we're not doing that. Okay, so if you don't know what each of these are, you need to be learning them. So which one is this?
Greater than.
Is greater than.
Is that a Fido?
No.
Oh, it's Jimmy.
I mean, hi
Jimmy.
What's the next one?
Jimmy.
Is less than. What's our next one?
Greater than or equal to. Okay, is it just like when we were like elementary school or whatever? They were not greater than or less than. It just said you pointed out whichever number is bigger. They would say like you wanted to eat the bigger number.
Yes. So I do feel like, in reality, no, that is not the situation. You should be learning those words, these words, at that level. The problem is that often as teachers, we want to find ways to help students remember, right? Very similar to PEMDAS. And right, we talked about how PEMDAS kind of has some big like flaws with it. But it was sort of a fix at the moment. Right, so the alligator eating the larger number is a fix at the moment. It works, you get a correct answer, but are you really learning the vocabulary you need to know? Well, no, right? And that just sort of snowballs, right? And then you sort of never learn the right one. So if you do want a trick to help you know that still keeps you with the vocabulary, this one opens like an L. That's our less than. Okay, so the one that opens the same direction that an L does is our less than. Okay? Now, there's a big difference between an equal sign and an inequality. And that difference opens a whole new door of things we're going to have to talk about. Okay, up until this point, we have been saying things like x equals 2. And actually, you don't need to write this down right now. Don't write this page down. You can just listen. X equals 2. What does that mean?
A certain number equals.
A number equals 2. How many numbers equal 2? A number. One number equals 2. Right? What does this say? Okay, so can x equal 2?
No.
No. So now the one number we actually see x can't equal. So what can x equal?
Anything above 2.
Okay, so how many answers does x have in that situation?
A lot.
More than a lot.
All. Like that.
And how many is all? How do we talk about that in the math world? An infinite amount of possibilities. So what's the first number that's greater than 2?
3.
How about 2.5? How
Yes.
about 2.1?
Yes.
How about 2.01?
Yes.
How about 2.001?
Yes.
How about 2.0001? Like, how long could we do that?
Forever.
Forever. So can anyone tell me the first number that's greater than 2? No. Right? 2.00000000000000000000000000000 for forever until we throw on a 1, right? But we can't really do it forever. So we can't write down the number that's greater, the first number greater than 2. Agreed? Okay. What does this say? Okay, so x is greater than or equal to 2. So does it, can x equal 2 in this one?
Yes.
Yup. What else can x equal?
Anything above 2.
So how many answers does this one have? An infinite amount of answers? Now, which has more answers? This one or this one?
The second one.
Right? They both have an infinite amount of numbers except this one has one more. I mean, when you're talking about infinite, saying one more is kind of a funny thing to say, right? But agreed it has one more. So, Brayden, for your homework assignment tonight, I want you to go home and write down every single number that's greater than 2. Why are your eyes really big?
Because that would take like my whole life.
That would take Brayden's whole life, and then even as he's dying, that's really morbid. There's still more numbers to write. Right?
It's like pi. It's never.
Yes. Right? So, since we can't write down every answer that x can be when we're talking about an inequality, we are instead going to represent every number that x can be. Okay, so there's one piece we have to introduce, which is we can graph inequalities. So you do need to write this down. Write this down in your notes. I'm going to pause here just for a second because Vita's trying to get caught up from her late bus. Oh, yes, Vita and Jimmy, when you get a chance, just turn that in. It's okay if it doesn't happen right this second, but yeah. Thank you. Okay, graphing inequalities is our way that Brayden is going to be able to go home and write down every single answer without actually having to spend his entire life doing it. Okay, so if we want to graph something like x is greater than 2, there are things we are going to have to consider. We are going to have to consider what this symbol tells us to do. Okay, so we're going to put this on a number line. Now, this is really like something my students have been told to do by some of their teachers, that like they should always put 0 in the middle of their number line. Putting 0 in the middle of your number line when you want to graph 147 is silly. So you do not need to have 0 in the middle of your number line. Here's what you have to have. You have to have this number on your number line. Okay, you're going to put that in the middle. And you need to have a number to the right of it and a number to the left of it. Okay, and think about it like we're just sort of zooming in on the number line, right? We're zooming into one particular place that we want to look. Okay? Now, we have to decide how we're going to represent a starting point for x is greater than 2. Okay, so what did we say? Can we write down the first number that's greater than 2? No. So is there a number I can write down here on the number line that I can mark this with? Nope. So Chrisma, do you have an idea?
Well, never mind. I was just gonna like, cause I know. So I was gonna say that, but never mind.
Okay, so instead what we are going to do is we are going to put an open circle at 2. Okay, right, most of my students go, okay, yeah, I kind of remember talking about this. Now, I'm going to give you some specifics here because, again, it sort of works at the moment in middle school, but it won't work long-term with inequalities at the high school. I don't want. I need this to be on the number line. None of this. Okay, please do not make my life miserable. None of this. Mrs. McKinney, that's an open circle. None of this. I mean, right? Like, we can be reasonable with an open circle on the number line. Okay, and that open circle says, I'm not including 2. 2 is not an answer, but I don't know how to say the number closest to 2. I can get as close to 2 as I want. I can tiptoe up to it closer and closer and closer and closer. I just can't actually be on 2. Okay, and then we want all the numbers that are greater than 2. So numbers on a number line that are greater than a number go which way? To the right or to the left?
To the right.
To the right. So we are then going to shade in all this area to the right. And we need to go over to the arrow, or if you don't go all the way to the arrow, you need to be showing that it continues going, because it's easier if you just go to the arrow. On the number line. Not above, not below, none of this. This is always one of my favorites. But Mrs. McKinney, I put it on the number line. Okay, yes, but like, please don't make my eyes hurt. Okay? Does that make sense? Yes?
Teacher said last year that a trick would be like wherever the like greater than or less than sign is pointing. That's like the way to do it.
It is kind of a trick. We're going to talk about that in just a minute, right? If you draw a line in here and make that be an arrow pointing, it will point the direction we need to go. So here are sort of your rules if you're a memorizer. If it's greater than or less than, you are going to use an open circle. Okay, but I want you to understand why. We are using an open circle because the number is not included, right? You told me that statement. If it is greater than or equal to, or less than or equal to, we are going to use a, closed circle, a filled in circle, a solid circle, whatever kind of word you like right there. Now, this rule, we're going to talk about here in a minute. If it's greater than or equal to, we are going to shade right. If it's less than or equal to, we are going to shade left. But those two things only work if the variable is first. Okay? Got it? Just gonna look at a couple weird situations. I don't know if weird is the right word, but. Y is less than or equal to -5. What number am I putting in the middle?
-5.
-5. And here's where my students sometimes mess up. What number am I putting right here?
4.
What number am I putting right here?
6.
Negatives feel kind of backwards. If you're like, Mrs. McKinney, I can't remember. Whenever we're moving to the right, we're always adding 1. So worst case situation, put in your calculator -5 plus 1. and -5 minus 1. Okay, open or filled in circle?
Filled.
Filled in.
Shade to the left.
Is our variable first?
Yeah.
Yes, so then we can just shade to the left. Now, overall, this is pretty much all there is to it. This isn't like anything that crazy. We just need to look at a couple other weird situations to make sure we would know what to do. Sometimes when we solve equations, we don't get nice, neat answers. So then what do we do? Okay, so let's make our number line. I mean, I know the majority of my students, and counting by fractions, much less having a fraction at all, is not where they would like to be. Okay, so we might have to do a little bit of approximating, and that's okay. Hopefully in 8th grade you did some approximating on a number line, but that was at the beginning of your 8th grade year. So what numbers are close to 3/4? 1 and
1/2.
let's not do fractions. What whole numbers are close to 3/4? 2, 0. Okay, and then we'll just approximate where 3/4 is on the number line. Is 3/4 larger or smaller than 1? Smaller. Is it a lot smaller than 1 or a little smaller than 1? A little, right? In fact, it's 1/4 smaller. We should be over here on the number line. Open or filled in circle?
Open.
Open.
Wait, can we make a little notch there?
Yes, if you want to, whatever. Is the variable first?
No.
No. So if we want to go by our graphing rules, we're going to have to rewrite this with the variable first. Which means we want this variable to be over here, and we want 3/4 to be over here. If we have to rewrite with the variable first, we have to flip this inequality sign. You kind of think about it like just you're flipping the whole thing, right? If you were to spin that whole thing, if there was like a stick down the middle here and you spun it, that symbol would also turn. I mean, your numbers would also be backwards, but that's a whole other discussion. Are we okay with that? So which way are we going to shade now? To the left, right? And we are shading on the number line. You okay? Okay, we're okay so far? One more you're all going to love me for. This is going to make you think back to 8th grade, probably, and be not happy. Don't touch your calculator.
Oh shoot, okay.
Uh-oh. Now, obviously you have your calculator, but I do want you to think about this because it's a middle school standard and we should be reminded on how to do this. What number should I put on my number line? Any thoughts?
No.
Okay, so do we know what the square root of 11 is? No, it is an irrational number because it's a non-perfect square, correct? It's a decimal that goes on for forever. We talked about that week 1. What is a perfect square that is close to 11? What could we take a square root of? Nope, we don't know what do we know a number times itself that gives us 10? Nope.
We could do 16.
16, right, is 4 times 4, so the square root of 16 is 4. Okay, so we definitely know that. The square root of 16 is 4, so that's probably reasonable to put on my number line. What else do we know that's close? The square root of 9. Okay, so if the square root of 9 is 3, and the square root of 16 is 4, 11 has to be somewhere in between 3 and 4? Is it going to be closer to 3 or is it going to be closer to 4?
Closer to 3.
Why closer to 3, Jesus?
I don't know.
Because it's only
Guess
two
we have to.
away.
Because 9 is closer to 11? I bet you did know, you just didn't know how to put in words, right? Be boldly wrong. If you're going to be wrong, you might as well be bold about it, because then you might be boldly right, right? 9 and 11 are closer together, so we want to be closer to 3. At that point, we're just kind of guessing. It's an irrational number. Open circle or filled in circle?
Filled.
Shading to the right or shading to the left?